Hello everyone and welcome to the course of 5G and EMF. You can find the full course at telcomaglobal.com. So let's start with 5G and EMF. So we have some facts related to 5G that 5G will use new radio technology and new frequency bands. Like 5G networks will incorporate the existing 4G LTE technology, but a new radio technology will also be introduced that meets the enhanced capability demands of 5G. To increase the capacity of mobile networks and support very high data rates, 5G will extend the range of frequencies used for mobile communications. So this includes new spectrum below 6 GHz as well as spectrum in higher frequency bands up to 100 GHz. Next fact is 5G equipment will use beamforming to improve the performance. To address the demand of increased performance, 5G base stations and devices will use many antennas. Arrays of up to hundreds of small antennas at the base station will make it possible to focus the transmission of radio waves to maximize the signals that the connected devices receive. This is known as beamforming or massive MIMO. Because of this technology, the transmitted power can be kept low, resulting in radio wave exposure at similar levels as in previous networks. Exposure levels will be below international safety limits. The power level of the radio signal transmitted by 5G radio equipment will be of similar magnitude as those used in the previous networks. 5G devices will be designed and tested to comply with established radio wave exposure limits. 5G base station will be positioned so that the exposure in homes and public area is below the limits. Public access will be restricted when needed, and exposure limits are set by independent organizations. Like independent expert organization has established the exposure limits for radio waves based on many years of research. The limits are recommended by World Health Organization and include large safety margins. 5G equipment, whether it may be mobile device or any base station, it may meet the safety standards as the equipment used in the previous mobile networks. So EMF and Massive MIMO. Like extensive research have been conducted into possible health effects of exposure to electromagnetic fields, including many types of radio signals. The World Health Organization states that the scientific knowledge in this area is now more extensive than for most chemicals. So EMF and Massive MIMO. The 5G will use advanced antennas that form beams and steer the radio signals in direction of devices. So it will improve the performance while keeping average power and EMF levels similar to those in the current networks that we are using. Higher frequencies and beam steering may cause public concern that needs to be addressed. Industry information is available like from Ericsson, GSMA and MWF. So EMF compliance challenges with massive MIMO, beamforming and beam steering. So what are the EMF compliance challenges? That we have large variability of transmitted signals in time and space. More complex EMF compliance assessments are there. Higher instantaneous equivalent isotropical radiated power than current antennas and potentially large EMF safety zones. Site design of increasing importance, since many existing sites already have small margins to EMF levels. Site compliance, very difficult in some countries having EMF limits below ICNIRP's international guidelines. So current EMF regulations focus on using the theoretical maximum transmitted power or EIRP to determine the compliance boundaries around the base station antenna. But when this approach is applied to advanced antenna array systems applying massive MIMO, it may lead to very large exclusion zones due to unrealistic power assumption, which may cause substantial 5G deployment challenges. So an alternative and more accurate approach is to calculate the compliance boundaries using the actual maximum transmitted power, which takes into account the available power is distributed over the beam scan area of the radio during EMF averaging time. For example, 6 minutes in the ICNIRP guidelines. For example, the actual maximum transmitted power of a 5G base station operating at 3.5 GHz will typically be 25% of the theoretical maximum transmitted power. The use of actual maximum transmitted power, including applications for 5G Massive MIMO base station, these are described in the standards of IEC, which is International Electrotechnical Commission, and ITU. For successful 5G network rollout and its importance, that ICNRP time average and the actual maximum power approach are adopted in national EMF regulations. ICNIRP as International Commission on Non-Ionizing Radiation Pattern. So, thank you.